So I'm back after a good while, and apologies for the radio silence, but I've been trying to learn Houdini a little more in order to be able to explain better what we're gonna discuss today, which I think it's the most important thing in Houdini. So attributes. What are attributes? Attributes, simply put, is information that flows through our geometry. And while this information in other software is hidden under the hood, in Houdini this information is exposed. So for example, I can grab this point and see what color value this point has, what temperature it has, where is it in space, what velocity it gets. So while these, as I said, are under the hood in Cinema4D, in Houdini are simply exposed to us. Before going further though into attributes, we need to address one more technicality, which is the way that Houdini interprets and draws geometry in our viewport. So what do I mean by that? Houdini differentiates the concept of points versus vertices, and while in other software this is the same thing, in Houdini it isn't. So what are points and what are vertices? In terms of visualization in Houdini, points are those blue dots, and you can define, here are some useful tools for visualizing. So with this we see the points, with this we see the point number, with this we see the polygon number, right? So 4 polygons. And with this icon here, we see those, what I was saying, the vertices. So the cyan dots are points and the pink circles are vertices. So what is the difference and why I have 4 here and 2 here and 1 here? Let me go to Cinema4D. So in Cinema4D, I have this plane and I'm cloning some small cubes here to show you this effect a little better. And I have, again, 1, 2, 3, 4, 5, 6, 7, 8, and 9 points, okay? If I use, but in terms of polygons though, let me, never mind. I wanted to change color so you see better. I have 1, 2, 3, 4 polygons. Cool? If I use a polyfx now, I still have 4 polygons, right? 1, 2, 3, 4, but I have 4 points for each polygon. So point 1, point 2, you see what's happening? So these are the vertices in Houdini. And the vertices are the points in space that draw a single polygon. And when Houdini doesn't have those separated, those polygons separated, they are still separated under the hood, but they are treated as the same object. Sorry, this is a little bit confusing. Again, what you see here now as red, these are the points. And what we see with white, these are the vertices. So the vertices are the points in space that create a polygon, and the points are the point in space where vertices meet. So for this point, let's call this number 1, for this point I have 1 vertex, because I don't have any other polygons right here. For this point, the point, let's call it number 2, I have 2 vertex. If I enable the polyfx, you see, I have 2 vertex, because polygon 3 and polygon 4 are connected here, therefore we have 2 vertices, right? For this point right here, let's call it point number 3, I have 4 vertices, because 4 polygons intersect in that point in space. So if I polyfx, you see now that 4 vertices exist here. So let me delete this doodle and enable this other structure that I have here to show this better. So where the black cubes are, these are my points, and where the red cubes are, these are my vertices. So again, because I'm trying to explain this as easy as possible, points and vertices are 2 different concepts. Vertices are the points in space that draw a polygon, and points are the placeholder for vertices, right? So points are where vertices meet in terms of polygons. So again, because here we have 4 polygons meeting, I have 4 vertices. Here, because I have 2 polygons meeting, I have 2 vertices, and so on and so forth. I hope this wasn't very confusing. This is a concept you need to grasp well. Not that we're gonna use vertices that much in Houdini, but you need to know that there is a difference between points and vertices. In most cases in Houdini, what you're gonna be dealing with is points, the places where vertices meet. And on those points, you assign values, you do stuff, and then you transfer these values to other things. But that's a little bit for later. Let's stick to the concept of how geometry is interpreted in Houdini for now. So now that we established that points and vertices are 2 different things, let's go back in Houdini and discuss the concept of those polygons here. So if I hover my geometry and press this I here, it pops up this window that gives me some useful information about the specific node that I am. And on top says things about what's going on in our geometry. So I have 9 points, remember the blue dots, 9 points. I have 16 vertices, the pink dots, whatever, and I have 4 primitives and 4 polygons. Polygons, we know what it is, but in Houdini, when we refer to polygons, we call them primitives. Let's ignore this thing for now, and let's keep in mind that whenever we refer to polygons in Houdini, we call them primitives, right? So this is another lingo difference between Cinema4D and Houdini. Again, points, vertices, and primitives are what we use in Houdini, and points and polygons what we use in Cinema4D. Of course, we have edges as well, but they don't play much of a role here because usually when we assign attributes and other stuff, we assign them to points or primitives. So keep in mind that lingo that is different between the 2 software, and keep in mind the concept of points and vertices that is also different. Another thing that caught me at first with Houdini and its geometry is, again, this primitive concept, right? So what we know in Cinema4D as polygon here is called primitive, but not only polygons are called primitives in Houdini. If I create a sphere, right? I have a sphere. By default, the primitives type is set to primitive. Let me show you the equivalent of that in Cinema4D. If I go here and create a sphere, this object now is parametric, right? This means I can increase the radius, the segment, change its topology and all that. So this is what primitives are in new objects in Houdini. These are the parametric objects, let's say. Maybe not quite that, but this is the same concept. And if I want to make this sphere to have access on its point and everything, I need to make it editable. And now the sphere is no longer a parametric object, but it's an editable object. So in Houdini, now this is a primitive, right? But if I change this to polygon, let me disable all those visualizers. Now this is what we call an editable object in Cinema4D, or if we change it to polygon mesh, a different kind of editable object, right? So when we say primitive, many times we refer to the parametric nature of our objects as well. So primitive goes for polygons, right? Polygons are called primitives. Parametric objects are called primitives in its basic form, although they can be so they cannot be adjusted. We do not have access to the points here, same as in Cinema4D. If my sphere is like this, I cannot go and grab points. I need to make it editable. Same concept applies in Houdini. As sphere is like this, I cannot grab any points or anything. I need to make it polygon or polygon mesh, therefore making it editable, and now I have access to points and all that good stuff. So again, polygons are called primitives, and parametric objects are also called primitives, as you see here. What else? What other parametric objects do we have here? We have probably a cube, right? Let's set the flag here. No, it's not a primitive. Let's see, a cube. I think a cube, which is a cylinder. Yeah, it is a primitive. As you see in this tube, I have height and scale as in Cinema4D, but I cannot access its points. In order to access its points, I need to make it a polygon, therefore editable as in Cinema4D. So again, I know I'm repeating myself, but very important concepts to grasp. Another important concept in terms of geometry, and I'll stop with this geometry thing already because I know I'm getting boring and tiring you with all this theory, but follow me. It will probably help you demystify things better than I do, because at first I was super confused about primitives and what is and what isn't and stuff like this. So I'm gonna go and create a line object, right? And let me enable the points, and let's increase the point count, right? And let's see also the point number in our viewport. So our line, here is where you're gonna curse on me, but our line, if we check the info, it consists of 13 points, makes sense, 0, 1, 2, 3, 4, 4, but from one primitive, and you will be like, and one polygon, and you will be like, what the actual fuck? So for simplicity's sake, and without going deeper into the geometry and how Houdini draws it, the lines are also primitives. So when we say primitives, we refer to polygons in Houdini, and we refer also to spline objects in general. Probably we refer to other stuff, as I know, but for now, this is enough information to get you started with this concept. Again, 13 points, 13 vertices. I think we understood the concept of vertices because I don't have polygons attached here. In both sides, there is the same amount of vertices and points, but the primitive, as I say, it's this whole line right here. So, geometry stuff out of the way, I think in a big extent, yes. So now let's finally start to see what attributes are. So as I was saying in the beginning, attributes are data that flows through the points and through the primitives and through the vertices. And while this data is exists in every software, in Houdini is simply accessible at all levels, right? So now that I have this grid here, if I press this flag icon again, I see besides the geometry information that I get, I also get this information about my attributes. So this grid by default has one point attribute called P, and P stands for position. So everything in Houdini, every object actually cannot exist without the P attribute, the position. So as you understand, the attributes are position, scale, rotation, color, UVs, normals, velocity, temperature, viscosity. All those things are unified in Houdini in a way, and they speak to each other very easy, as you will see later on. While in Cinema4D, I cannot just color something and pass this color to temperature. It's not as easy, but here we can do these things very, very easily. So think of attributes as a unified flow of data, like a unified stream of data that flows through all of the aspects of our geometry. We define how and when we use and what attribute, and this is also the power of Houdini, because if you have a mesh that has too much information on it, the scene becomes heavy and slows down. But if you have the mesh that has the right amount of attributes that you need for an exact operation, the scene becomes much less heavier, much lighter, let's say. So this is also apparent if you export things from Houdini to Cinema4D, and we're gonna try that in a bit. If we have a ton of attributes there, the alembics are very big. But if we strip our thing to the minimum amount of things that we want in there, our alembics will become much smaller. So back to the attributes, right? Right now I have the point attribute, this is default. And let me go and add a color shop here and change the color to red. And check the info of this node. Now I have in my points one, besides the position, I have also this C, capital C, lowercase d. And this stands for color diffuse. So P stands for position, CD stands for color diffuse. So without looking at my viewport at all, I know only by the info that I have color on my object. I don't know what color just yet from this info panel, but I know that I have color besides my position. And you will probably say, why do you need to know this information written? Why you can't see at your viewport? Well, some attributes are invisible, like for example, the viscosity. How do you know where your liquid has viscosity? Or how do you know where your smoke has a higher temperature or a higher burn value? Obviously with smoke you can see that during rendering, but here we can see it like in a way that it's more easy to interpret and fix your mistakes later on. So we've seen the P attribute, we've seen the color attribute. Let's go and add another geometry attribute. Let's add some normals. And if I enable the normal and check the info again, we have the P, the CD, and I have one vertex attribute called N. N stands for normal. And you probably say, why is this a vertex attribute? By default, when you assign things, besides the position of our grid, also in the color, it has here this class. And class refers to our geometry. So I can have color on points, I can have color on primitives, doesn't make any visual difference in this case, but you will see another example in a bit. And normals, for example, add normal says here to vertices. I want normals to points or to primitives. So let's leave normal to points and the color to primitives and check our info again. Now I have 2 point primitives, the normals, the P, and one primitive, 2 point attributes and one primitive attribute, the color, right. So you see that we very easily change classes on our attributes and assign them to different parts of our geometry. And this is really important because other times you need attributes on points, other times you need attributes on primitives, and other times you need attributes on vertices. This amount of control does not exist in any other software. So let me take a pause here and jump back to Cinema4D and show you that while somehow the P attribute, let's say, from Houdini can be examined in the structure manager here, right? The color, the CD attribute that we have I cannot find that. I just have, I visually see it. If I was like this, without textures in my viewport, I wouldn't be able to know that this thing, and this was, let's say, hidden in a null, I wouldn't be able to know that I have color here. And you probably say, yeah, fuck off, just open the null and check. Yeah, of course, but as I mentioned, some attributes are kinda invisible, right? Some attributes can be just values where you take things and you assign to those values. So let's leave Cinema4D now and go back in Houdini and delete these two. And I'm back where I was with just a single P attribute. Let's go and start randomizing our attributes. now and make this a little bit more interesting. So attribute randomize. And let's give some rows and columns here to our object. And now we see something different. And let's check on attribute randomize. What attribute are we randomizing now? We are randomizing our class's points, so we are giving color to our points, and we're randomizing the CD. The CD is what we learned from before, the color diffuse. So for every point in our geometry, we're giving a different CD attribute. And the values of the CD attribute are defined down here where it says minimum and maximum value. So I can go and say, it has many options here. So I can go and say 2 values, right? And it can range from 0 to this. Okay, these values stand for RGB. So, you know, I don't want to confuse you with the settings much right now. So let's just focus. Let's delete what I did here and let's just focus on working on this plane, on this grid actually. So for every point, I'm giving a different color value, a random color value. I can change the class to primitives, and now for every primitive, I'm giving it a different color value. So this is kind of something like the random effector, but it works direct on geometry, and it can randomize anything from color to normals to anything. And this is, as I said, a huge advantage. So another question that comes in mind, how do I know which attribute to type here? Well, there are attributes that are known, like in Houdini. For example, P, capital P is a known attribute. C, capital C, lowercase d is also a known attribute. Let's take another known attribute that's called P scale. And right now, the P scale, we do not see what it's doing, but it's assigned on primitives. And let's double check. I have a P scale attribute that it's assigned on primitives. So if I change this to points, now our points have a different P scale value. And P scale stands for, it's the uniform scale, let's say, right? And we can clearly see that if I use a copy to points is like a cloner, and I'm gonna clone some spheres onto this grid. So without the attribute randomize and with the attribute randomize. So we see that we're taking this point attribute that we created here, we're passing the data through on this copy to points node, and sphere inherits the point attributes that we created on this stream, right? So things are starting to get a little more interesting. So because I have a MoGraph background and we do everything on Cloner, I'm going to continue with this example and add another attribute, let's go randomize and place it in line here, and boom, this attribute randomize now randomizes the color diffuse that we know. So if I do this info again and check, I know that I have 3 point attributes. I have data on my points, and the data that I have is color, position, and uniform scale, P scale. Let me go here. Let me stop again here and jump a little bit to Cinema4D and examine this file that I have. So a similar thing happens in our cloner object right now. So the cloner by default has a lot of attributes inside it. Has color, has UVs, has position, has normals, has everything. You don't have to define all these things for the cloner. That's why the cloner is much heavier than a copy to points node in Houdini. Because in copy to points, we define what we need. While in cloner, look, I just have the color attribute here. That's it. I don't need to define it. I have the scale. I have rotations. I have everything. So what do I do with effectors in Cinema4D? I am simply manipulating all the attributes that our cloner has. So for example, if I use a random effector here, this random effector affects the rotation of our objects. You see? Rotation. So this is not the same as adding an attribute randomize. It actually it's similar, but as I said, the cloner contains all this information, while in Houdini, you go and define all this information, because without this attribute randomizing color, this has no color information right here. It only has position, right? It's colorless. We need to define that, while in Cinema4D, as I said, the cloner can still be colorized, even if I don't give color from the random effector. I hope that makes sense. What else we can do with attributes? Infinite amount of things, like passing the data from one node to another and do fancy stuff. But before going into that, I'm gonna create an arbitrary, let's say, attribute. So let's go and duplicate my grid. I hope that my examples are not very confusing. I will get into more depth in stuff, but for now, I'm trying to give you a generic sense of what's going on. So I have this grid now, and let's add attribute randomize, right? And I don't want to color I don't want to use the CD attribute. I want to create my own attribute and randomize it, which is called Thanos. So even if we don't see visually the Thanos attribute here, every point of this grid has different values on it. So if I go to info now, I have the position attribute, and I have also the Thanos attribute, right? So how do we know that what this attribute does in more depth? So as Cinema4D has the structure manager, here to examine attributes in a better way, of course you can visualize them, I will show you that, but in order to examine them in a better way, there is here this very scary geometry spreadsheet. So geometry spreadsheet is what this info panel is giving us, but in much more detail. So for instance, I see here, I'm on the node attribute randomize. These are the point numbers, right? And this is the position attribute, but in detail now. So for point 0, I have position -5, etc., etc. What we had in the structure manager, but we also have an attribute that it's called Thanos and is contained of 3 components like the X, Y, Z in position. And this attribute Thanos, as you see, has random values in it, right? Let me address another thing here. So why 3 values in each point? Now it's a good time to discuss about the types of attributes. And the most basic types of attributes that we have are vector attributes, which are consisted of 3 values like position, X, Y, Z, normals that also point in 3 directions, X, Y, Z, so this is also a vector attribute, and float attributes. Float attributes, there are more types of attributes, but these are the most basic ones in Houdini. So float attributes are a single value attribute. And how do I define that Thanos is a float attribute in this case? So in the attribute randomize, where I created this Thanos, by the way, when you throw an attribute randomize and write something here, it creates also the attribute for you. Even if it doesn't exist, it creates it. It has these dimensions right here. So if I throw this down, you see that I also have 4 dimensions. I don't want to confuse you with that, but 3 dimensions is a vector attribute and 1 dimension is a float attribute. So every point now in my grid has values from 0.99 to 0.00 something. So now what I can do with this Thanos attribute is I can throw a color again here, and I can use the attribute that I created to colorize. Right now you see here that it has color RGB everywhere, 111, which means it's a pure white. You see, I don't need to see this. I know from here that this is a pure white object from the points that I see. And what we can do with this color attribute is, instead of color type constant, I can go and say ramp from attribute. So it immediately became black. And what I want to use, what attribute want to use? I want to use the class point, because I created this point attribute Thanos, and I can also see it here. So for example, here in the geometry spreadsheet, these are the points, the vertices, the primitives. These are details, we won't talk about it right now. So I know that I have a point attribute called Thanos, and I need to use this attribute to colorize something. So here in the list, I can just type Thanos, or because I'm on the correct class, you will probably find here, it's a bit off screen, but you will probably find here, if you press this arrow, that Thanos exists, and color node realizes that and grabs the Thanos attribute and maps it. So let me actually increase the grid count to 100 by 100, so this is more apparent. So now we see that I have a range for my attribute. I can clamp it, I can change the color here to whatever, orange and blue, whatever. So now you see how powerful the attributes are. I created something arbitrary that doesn't exist anywhere, and I mapped it to some other thing. Cool, very cool. And let's say that the attribute that I created, I don't want it on points, I want it on primitives, and therefore, because the color node doesn't match the class of the attribute that I have above it, if I change this now to primitives, you will see it colorizes every polygon. While before, if I set this to points and these 2 points, it gives us something like a vertex map, like it uses the color here and blends with the other vertices. But let's use primitives, which is more apparent. And now we have this range of random colors and defined colors in our stream. Cool. Let's decrease this to 20 by 20, so it's more apparent. And you also see here in the geometry spreadsheet that because my attribute is on primitive, is not here on this list anymore where I see the points, but it's here on the primitives. You need to select your node, right, and have it enabled. So the attribute randomize, it's here in the primitives, but not in the points. And the color, it also created this CD attribute right here for us. Cool. Now, the power of that is, as I said, the attributes are a unified system. So what I can do with this attribute randomize that I created. So by the way, if we're on an attribute like this, we can create a visualizer for it. So by having the attribute like this and pressing X, it drops on the side this visualize node, and I need to go to this node, to visualizer, and change the name to what my attribute is. So it shows me now the attribute randomize information. So black is the 0 value and 1 is the red value, etc., etc. So this is how you also see visually your attributes without looking at your geometry spreadsheet or anything. And always dropping a color and checking what's going on is a good idea, but as long as the color has the ramp in its place. Now that the ramp has been clamped, it doesn't actually correspond with what I'm seeing here. Sorry, this might have been confusing, but I had to get it out of the way. So as I was saying, what I can do with this Thanos attribute? Well, if I throw now down a poly extrude node and place it here, and increase the extrude distance and go where it says connected components. I want individual elements. So let's take the inset just a tad. So you see now we're extruding our polygons, primitives individually. In the poly extrude now, every node usually has attributes in it. Attributes that control various stuff. So for example, in the extrude node, what I have here is if you go where it says local control, it has this distance scale attribute. And this distance scale, Z scale, is how tall our extrude is. But this is called Z scale and this is called Thanos. So if we take the Thanos now and rename it Z scale, scale, boom. Now this arbitrary value attribute that we had before, because it matches the name of this here, it creates this randomness. So again, from attribute randomize, I can select the minimum and the maximum randomness and do all kinds of things. But you see that using the same thing, I'm controlling so many stuff together. And let's check the color node now here. And now that I changed the name, the color node lost it. And this is because I need to go here again and change this to Z scale. Scale. So the attribute name needs to match in order for things to work proper. So attribute randomize, Z scale, and Z scale. And the Z scale doesn't work in this case because they are all up, but actually it should work, I think. Let's take the attribute randomize and yeah, the minimum value is too much, right? So now it's working proper. So where we have 0 Z scale, they are yellow, and where we have 1 or more Z scale, they become blue. So you see the procedural nature of this thing and what attributes are capable of doing. What I can do next, poly extrude, for example, has some other attributes. It has the twist scale. So let's go to our poly extrude, and in the extrusion here in the settings, let's add some twist. Let's add some divisions here so we see the twisting. And if we go to our locant control and rename this twist scale to Z scale as well, now it uses the same randomization. I don't know if you without it and with it. Some are more twisted than the others, and everything is based again on this attribute randomized value. So you see that I'm using a single value to control everything. I know maybe this is a little too much for you, but let me quickly jump to Cinema4D and show you the exact same concept here in order to probably understand it. Although this is a little bit of advanced MoGraph, but bear with me. So we randomized the cloner rotation, but let me hide the child and let me go to the clone and say weight. So let's suppose that these are the points from Houdini that we give them random attributes. We can give from random effector, even without the rotation, we can go where it says weight transform and maximize it. So I don't know if you see that these things turn orangey, and let's go and make it random so you see that much better. So what I'm saying is I'm giving the same arbitrary value. The weight is what is called Thanos in our case, inside Houdini. So I'm giving this arbitrary value in our points, and then I'm going to use this information to drive other effects. So if I enable the sphere again, while the weight hasn't done something to the sphere, we can use another effector, as we can use another node in Houdini to get advance of this attribute. So in my case, I'm using a time effector, and in the fall off, in order for the time effector to access the weight of our cloner, you need to drag your cloner here in the fall off as a MoGraph object. And then if I enable, the time effector is something like time in After Effects, where things constantly move or constantly rotate in a linear fashion. So I have a position in our time effector that goes up on the Y, I have a rotation, and I also have a color. So if I enable the time effector and press play, I'm using the weight transform, you see? I'm using the attribute that I gave, the weight attribute in this case, and this weight name can be anything, but I'm using the weight attribute in this case to pass it to the time effector, and the time effector do its magic. So again, in the effector here, I can play with the values, min and max, and whatnot. It can be a noise instead of a, you see, this is a noise attribute in this case, but maybe this is easy to show you the concept, right? I'm masking one effect with the other via an attribute that does nothing without defining it. So, as I was saying, this corresponds to this randomize z-scale that we gave, and we were calling it Thanos before. So this is what was revolutionary also for me in Houdini, and revolutionary. This helped me understand it better when I took this attribute randomize and called it weight, for example, as in Cinema4D. It doesn't matter the name, weight, and everything got lost. But if I grab this name now and pass it everywhere, I have the exact same example, because weight is just a name, just an arbitrary value that we take this weight and we say to this weight, do something, map the weight to color, map the weight to how much things scale, map the weight to anything. Confusing? Yes, no, probably I didn't explain things very well, but it's been very difficult to bridge this gap between Cinema4D and Houdini in a good way. But I'm gonna take a small stop here because this tutorial is dragging a little bit too much, and I'll be back with a second part of attributes, where we will discuss in more details and we will see some more advanced, let's say, examples of what attributes can do. So a small recap. Attributes is information that flows in our geometry, flows through points, flows through primitives, and we need to have and we can take this information and assign it in wherever area we want. We're completely free in Houdini. We can assign this the attributes into color, into temperature, into z-scale, into extrude, into bevels, into remeshing, or whatever you can imagine that it's not possible in Cinema4D, it's possible, in Houdini via particles. So via attributes, I'm Thanos, I love particles, but this is happening via attributes. Then the other important thing is for things to match, because if the class doesn't match with what you're creating here, so because now this is a primitive attribute called weight, if I'm on the color and have a point attribute called weight, it won't throw me an error. It's just not gonna work. So 99% of the times is when your attributes are not working is because the class is not matching. So thanks for being here with me in this very, very long tutorial. Hit me up with questions below or anything that I can help you demystify what's going on here. And I'll come back with part B when I have some more time to show you some more advanced examples on the same concept. So thank you very much. See you soon. Ciao.